So you saw how to make a singly linked list in my last video and how we can only traverse it in one direction. But doubly linked list changes all of that by giving us the ability to have the reference to our previous node as well. Therefore, in this video, we will see how we can implement doubly linked list in JavaScript and how you can implement LRU cache using doubly linked list in React.js. So this is what a doubly linked list is all about. This has a data, it has a next pointer and a previous pointer. And similar to our singly linked list, it has a head and the last node points to null. So let's see first how we can create a doubly linked list. So obviously we need to create a node first. This one single entity, as I mentioned in our linked list video, is called a node. So I'm going to create a node class node. And we're going to initialize this class inside of this constructor with some data. And this data will be assigned to this dot data equals data. And obviously, since we're going to have a previous pointer and a next pointer, I'm going to say this dot previous equals null. By default, obviously is going to be null. And this dot next is going to be null as well. So yep, this is what our node is going to look like. So let's create the actual doubly linked list now. But before we do that, hit that subscribe button right now if you want to see more such videos like this, because you won't find content like this anywhere else on YouTube. So I'm going to say class doubly linked list, and I'm going to initialize it this dot head equals null. So by default, our head will point to null. Since our doubly linked list is empty, this head will be pointing to null, right? So okay, let's discuss all of these functions one by one, how we can add something to the top of the linked list, to the end of the linked list, inside of the middle of this doubly linked list, how we can remove from all of these places, how we can traverse through a doubly linked list, how we can print it, and so on. So first thing first, I'm going to open this visualgo.net and okay, let's see. So we have a doubly linked list over here, right? Let's say if we want to add something at the top of our linked list. So I'm going to say insert on the head. So let's insert 39. Okay, let's click on go. And did you notice what just happened? It introduced a new node over here, first 39. Then what it did, it pointed to the head of our linked list. And the previous pointer of the head will point to this new node. And in the end, what we will do simply, we're gonna assign this as the new head of our doubly linked list. So yep, I'm gonna create a new function called add first. This function will take some data since we're supposed to add it inside of our linked list. And I'm gonna create a new node out of this data. So I'm gonna say const new node equals new node. And I'm going to create a new instance of this class node. So okay, this is going to receive a data, so I'll just provide it with this data over here. Now since we have this new node, what are we supposed to do? We're supposed to point it to our head, right? So I'm going to say new node dot next will be equals to this dot head, simple. And now I'm going to check if this dot head, that is, if we already had something inside of our linked list, if the head already existed, then I'm going to say this dot head dot previous to our new node, just like that. And in the end, this will be made the new head of our doubly linked list. So this dot head equals new node. As simple as that. Let's see how we can add something to the end of our linked list. So the only logical thing to do is to traverse through this linked list until we reach the very end and then repeat the same process. We're gonna basically point to the tail will point to the new node, and that is how we can add it inside of our doubly linked list. So I'm gonna say add last. It will take our data as well. I'm gonna create a new node, and then first of all, we have to handle the edge cases, right? So I'm gonna check if head doesn't exist. So this dot head, oops, not of this dot head. So if head doesn't exist, then I'm just gonna add it over here. That will become our head and the last node as well, right? So I'm gonna say this dot head equals new node and simply return it. But if that is not the case, then obviously we will traverse through our linked list. So I'm gonna say let current equals this dot head, that is, we are assigning this current variable our head, and then we can move by doing current.next every time. We can move it to the very end. So I'm going to run a while loop for that. So while we'll have a condition of current.next until we have something in current.next, then keep on doing this. So current equals current.next. So this will essentially keep assigning the next variable to the current, and this is how it will move to the very end of our linked list. Now, since we are at the very end, I'm going to say new node dot previous equals current, and current dot next equals new node. So in this case, current is this over here. So if you were to insert something on the tail, let's say 50, and so you see we got this data at the very end. Then what we did, we pointed its previous to the current node, we pointed it previous to the current node, and we pointed the currents next to our new node, just like that. And this is how we can add some node at the very end of our doubly linked list. All right, now that was an easy part, but let's see how we can add at some specified index inside of our doubly linked list. We want to add something at the very middle. So okay, I'm gonna insert specify both. Okay, I'm gonna insert at the third position, and let's go for 19. Go. See what's happening. It's traversing through it. It's doing next, 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 and yep, it found that this is the third position. Now we bring our data over here. We pointed its next to our data. We pointed the previous of our data to that node, and then see what happens. And then we did the same thing with the previous node. So whatever the current node was, we're going to point the next of the current.previous node, that is this node. This is current.previous. So current.previous.next equals to our new node, and our new node.previous will be equals to current.previous. So this is how we can insert the node at the very middle. Let's see the code for it. Add at. And I'm going to take two things, obviously, index and a data. Now we're going to first handle the edge cases. So if index is less than 0 or index is more than this dot size. So obviously we haven't created this size function yet. So I'm just gonna leave it empty for now. We're just gonna create it in just a moment. So if that's the case, if index is less than 0 or more than the size of our linked list, then this is a error, right? So I'm gonna say console.error invalid index, and then I'm gonna return it. If that is not the case, I'm gonna create a new node. So let's create a new node, and first of all, I'm gonna check if it's at the very first end. What if the index is equals to 0? Then we're supposed to insert it at the head, right? So if index equals 0, then we're gonna simply take this code over here, add first. So put it over here. We have already created a new node. So yeah, this is what we need to do. But if that is not the case, I'm gonna traverse through this. So I'll just take this, let current equals this dot head, and I'm gonna traverse it one by one. So I'm gonna run a for loop to that very specified index. So for let I equals 0, I less than index, and I plus plus. And inside this, I'm gonna just do current equals current dot next. Now this will run until it reaches this specified index where we're supposed to insert something, right? So okay, after this loop, we have reached there successfully. Then I'm gonna say new node dot previous to current, and new node dot next to current dot next. So what have I done over here? I have taken this over here and I'm saying new node dot previous to the current, so that the previous of this one will point to this one, and the next of this one, that is next of this one, will point to this one over here. So actually they have different implementation, a little bit different implementation on their website. What I like to do is I like to insert it with this one over here, since I'm taking I less than index. So okay, this previous will point to this one, next will point to this one, and the next of this will point to this one now, and the previous of this one will point to this. So simply I'm gonna say after it, if current dot next has something, then make it point to this one. So if current dot next has something, then I'm going to say current dot next dot previous will be new node, and the current will obviously be pointing to this one over here, right? So in the end, current dot next equals new node. As simple as that. Let's quickly write our size function. So we don't actually have to do anything over here. We just need to take a variable called count, assign it to 0 by default, and I'm just gonna traverse it. So whatever that we're doing over here, actually over here, I'm gonna paste it. I'm gonna run it to the very end of our linked list, and I'm not gonna do dot next. I'm just gonna do while current has something, then keep doing current dot next. And meanwhile we're doing that, I'm gonna do count plus plus, and this should give us the size. So return count. That's it. Alright, now let's see how we can remove the first element of our doubly linked list. So I'm gonna create a new function over here, remove first, and let's see. So let's say for this linked list, I'm gonna click on remove from head. So notice what happens. We're gonna simply do, since this is our current head, right? If you want to remove this from our linked list, we can make this one our head. So this will cease to exist. So that's all. So I'm gonna say if, first of all, let's check the edge case. So if this dot head, if there is no head at all, then we don't need to do anything. We can simply return it. Else this dot head will simply be this dot head dot next. That's all. And then after it, if we have something inside of our head, this dot head, then this dot head dot previous equals null. What we're simply doing over here is, this was our previous node to our head, right? We're still pointing on to it. So we're gonna do this dot head dot previous to null, so that we are not continuing to point this node over here. So that's why we've done this. Now let's see how we can remove something from the very end of our doubly linked list. So remove last. Now first thing first, I'm gonna do the edge case check. So if this dot head is null, then we're gonna do return. Else I'm gonna check another edge case. If this dot head dot next, if there is nothing after our head, then obviously this is the only thing inside of our linked list, and we can simply make our head null to remove that. So we can say this dot head equals null, and we can say return. Okay, these two edge cases are handled. Now we can go on to traverse through our linked list, and we can reach the very end of our linked list, and then when we reach the end, we can remove that particular element. So okay, I'm gonna say, let's take this, and I'll put it over here. Let current equals this dot head, and this is actually a little different condition. So I'll say current dot next dot next. So why are we doing this? Why are we checking for next dot next? Because we want to stop over here. When we come over here, we can stop over here, and we can just point the next to the null. So current equals current dot next. So we've reached at the very second last element. Then we can do current dot next equals null. Yep, that's all. Cool. Now let's see how we can remove something at a very specified index inside of our linked list. So I think it's gonna be very similar to this one over here, add at. So I'm just gonna pick it. I'm gonna paste it over here. I'll say remove at. It's gonna take just the index, not the data, and we're gonna not create a new node. So first of all, obviously we're gonna check if it's an invalid index or not. So yep, but if the index is equals to 0, that is it's at the head of our linked list, then simply we can do this thing, remove the first element. So instead of this code, I'm just gonna say this. If that is not the case, then we're gonna traverse through it. We've traversed through it and we've reached index. So we're not gonna reach index, we're gonna reach index -1, just one element before it. Let's say if we're supposed to remove this, we can reach over here so that we can point this one to the next of this node, right? So let me show you. So -1, we've reached over here, and we're not gonna need these two lines. Now I'm gonna check if there is something after our current node. So if current dot next, then current dot, we just remove that, current dot next equals current dot next dot next. So might be a little bit confusing for you. Let me show you first of all. So let's remove the third one. Let's go. Okay, we're traversing through it. Okay, we've reached over here. So, oh, that was too fast. Okay, so we've reached over here. This is our current index. So to remove this index, I'm gonna simply point it to this one. So see, you see, I've pointed it to this one, and now this node over here is isolated. So yep, it's gone. So current dot next, that is this dot next, will be equals to next next. So this one over here. So current dot next equals current dot next next. And then I'm gonna say current dot next has something. So I'll just say if current dot, keep in mind this is a different current dot next. This current dot next is this one, not this one. So current dot next, and I'm going to say current dot next dot previous to current. Yep, that's all. Cool. I think we've covered all of the major functions. Let's write how we can print our linked list, and I think that's pretty easy. We just need to traverse like we did for our size. So I'm just gonna say, I'm gonna take this one, and after that I'll have a while loop which is gonna check if current has something inside of it. Then just do console.log the current element, so current dot data, and obviously I'm gonna move current by one position, so current equals current dot next, just like that. And yeah, I think this should do it. Let's test out our linked list. I'm gonna go back to our linked list. I'm just gonna pick whatever that we did over here, and we're gonna check it one by one. Okay, instead of this linked list, I'm gonna say doubly linked list. Oops. I'm gonna call it DLL for doubly linked list. All of this as DLL. Okay. So let's check this one by one. I'm gonna remove everything for now. And let's open up the terminal. And let's run the doubly linked list. Okay. So we've added the first element as 5. So we can see 5 over here. Okay. Let's add another element over here. So we can see we have 3 and 5, and the size is currently 2. Alright. Let's add 2 more. 8 will be added at the top and 6 will be added at the bottom. Yep, that's what happened over here. Okay, let's remove 5. Oh, so I mean 8. Whoop, what happened? Remove top is not a function. What did we name it? Remove first. Okay. Remove first. Okay. Let's see. Yep, it removed the first element. Let's add at the second index. 0, 1, 2. So it added at the second index. Alright, let's remove the last one. We have removed the last one. Let's remove the second one. Yep, we've removed the second one as well. Awesome. And yep, that is how you build a doubly linked list from scratch in JavaScript. Now is the interesting part of our video. We're gonna take our doubly linked list and we're gonna implement the LRU cache that we had implemented in our previous video using React.js. But before moving forward, I need to tell you about my DSA book. So if we scroll down and we go to linked list, you can see we have a bunch of different questions on linked list and even on doubly linked list as well. So I'm going to show you how you can implement LRU cache in React.js. But if you need to just practice the logic of LRU cache, you can click on this link and you're going to directly be taken to the problems page where you can practice how you can implement LRU cache by using doubly linked list. And we have a bunch of different questions as well on linked list, sorting, searching, queue stacks, and a lot of other data structures as well, which you need to crack big tech companies. So click the link in the description down below and download my DSA in JavaScript ebook. This is the only resource that you need to practice DSA in JavaScript questions for your interviews. Alright, so here we are in our code sandbox where we implemented the LRU cache in our linked list video. So let me just give you a quick recap. We have created this component dynamic content loader over here, which what simply it does is we have created a LRU cache, which I explained in the last video, it has a certain capacity of 3 which caches the element as we click on it. So let's say if we click on tab 1, it has cached the tab 1 inside of the LRU cache. So you can see we have one object. If we click on 3, then 2, it has cached those as well. So it can at maximum store 3 items, and when we, let's say, now access 2, it's not going to fetch it. It's just going to take it directly from our cache. So if we click on tab 2, yep, you see it was instantly loaded. But if we click on tab 4 now, you're going to see it's being fetched, and now the oldest or the least recently used item was removed from our cache, which was first element over here, right? So yeah, so simply to implement this, what we did was we created this custom hook called use LRU cache. So if we go inside of our use LRU cache, we have different functions for get, put, adding to front, removing from the last, moving to the front, etc. And we don't need to make changes to this part over here, just simply taking all of the functions from our LRU cache. So okay, so to make changes on this LRU cache, which was implemented by just using singly linked list, I'm gonna create a doubly linked list. So all right, I'm gonna have a class node. I'm just gonna minimize it for now because we don't need it. So we're gonna have a class node, and actually we can use the same node class that we created over here, just like this. Now we can create our doubly linked list class, and inside of this I'm gonna have a constructor. Now I'm gonna show you a little different implementation of doubly linked list. In this implementation we use head, and we also use tail. We keep the track of the position of our tail, so to make our life easy. And we're gonna directly use size over here, and we're gonna update the size every time we make any changes to our doubly linked list. So okay, let's write the functions inside of this doubly linked list class. So first of all, if we go back to our previous LRU cache, we can see we had add to front, which is going to be adding a new content to our LRU cache. And we had removed last, so that if we the capacity of our LRU cache is filled, we can just simply remove the least recently used item from our cache. And then we have move to front. So if we let's say what do we have over here? We have 2, 3 and 4. So if we, let's say, click on 3 again, it's gonna be taken from the cache and it's gonna be made most recently used. So notice, no, not over here, over in the head, yeah, you can see we have 3 with the ID 3, tab 3 attached. So it was brought at the very top of our LRU cache. So this is that is when this move to front will be used. So okay, let me minimize it again. Let's start with add to front. So add to front. Now this add to front will take some data, which is a key, and I'm gonna create a new node out of this key. So const new node equals new node. I'm gonna give this the key. Simply now for adding something to the front, first of all we're gonna check if does it has something inside of its head. So if this dot head is null, if head is null, then simply we're gonna assign it to our head, right? So this dot head equals new node, and this dot tail equals new node. So notice how I'm keeping the track of the tail as well. Whatever we keep inside of the tail, we're keeping the track of that node inside of over here. In this case it was just one element, so this will be the head and tail both. Else if that is not the case, then we can simply say new node dot next will be equals to this dot head, because we're supposed to add it at the very top of our doubly linked list, right? So the new node dot next equals this dot head, and then this dot head dot previous will be new node, simply as we did while we were inserting at the very top. If you notice, yep, this is how we do this. And then in the end, simply we're going to say this dot head equals new node. So this dot head equals new node, as simple as that. And along the way we can update the size of our linked list as well. So since we have added something inside of our linked list, I'm going to say this dot size plus plus. So this is much easier way to update the size instead of just creating a function. We're just keeping it updated along the way so that we have the global access of this dot size. And then simply I'm gonna return new node, signifying that we have added it inside of our doubly linked list. All right. After this, we're gonna implement remove from end. So remove from end. So since we are keeping the track of our tail, this is gonna be much easier for us now. So first of all, I'm gonna check if there is nothing inside of our tail. So this dot tail is null. Then we're not gonna do anything. We can just say return null. But if that is not the case, I'm gonna say const removed node, and I'll say this dot tail, because that is what we're supposed to remove from our doubly linked list, right? Then I'll say if this dot size equals to 1. So after removing our tail, we have not removed it yet, but we will remove it soon, don't worry. So we're just taking this removed node variable over here. So before removing it, if this dot size was equals to 1, then obviously there was just one element. So I'm just gonna put our head and tail to null. So I'll just take this and I'll say this dot head and this dot tail to null. But if that is not the case, if it had something more than one element inside of our doubly linked list, I'm going to say this dot tail to removed node dot previous. So let me just show you. So this is our tail, right? So if we're supposed to remove something over here, what I'll simply do, I'll point this to this node over here, and the next of this will be pointed to this over here, and this, the one in the middle, will cease to exist, just like this. And then simply I'm going to say this dot tail dot next equals null. After this, since we have removed something from our doubly linked list, I'm going to say this dot size minus minus and return whatever that we have removed from our linked list. So removed node. Yep. So now let's implement move to front. This can be a little bit tricky, so try to pay full attention. So inside this move to front, I'm gonna provide it some node. So first of all, we're gonna check if the node is already at the very front of our linked list, then we're not gonna do anything. So I'll say if node equals to this dot head, then I'm gonna say return. Else, wherever this node is inside of our linked list, I'm gonna take it from there and then put it on the very top of our linked list. So if node dot previous, if it had some node before it, then I'll just say node dot previous dot next equals node dot previous. And if it had something after it, so node dot next, so I'll just say node dot next dot previous to node dot previous. Actually, this first one will be node dot next. So let me show you what I've done over there. So let's say this was our node. So if it had something before it, I would have just said node dot previous, point it to the next. And if we had something after it, we would have said node dot next dot previous and point it to this, so that this will no longer be here. Right, so we have removed it over here, and now we can take that particular node and we can assign it to our head. Yep, that's all we need to do. So after this, I'll say if node is equals to this dot tail. Okay, so we have one more condition to check. So if node is on the tail, then we can remove it from our tail. So this dot tail will be equals to node dot previous. So basically what we're doing over here is if it's anywhere except our head, then remove it from there. And then after we have removed it, I'm going to say node dot previous equals null and node dot next equals this dot head. Simply we are just inserting it onto our head, and this dot head will now be our node. Also, we need to point the next node after the head to this node, right? So before this, after we have pointed it to the head, we need to do this dot head dot previous to node, and then we can replace our head with the node. Yep, that is all. That is all we needed to do to implement majority of these doubly linked list functions. So all right, let me just close it and let's go back to our LRU cache, and we can implement it by using our newly created functions. So okay, we're gonna use this dot capacity. Okay, we're gonna create a new cache. Now instead of this, since we've moved this logic inside of our linked list, I'm just going to say this dot order equals new doubly linked list. And inside of our get function, let's see if the key already exists inside of our get function, then we're going to do move to front. So instead of this dot move to front, I'll say this dot order dot move to front, or you know what, instead of order, I'll just say DLL for doubly linked list. Okay, so to get something from our LRU cache, we can just provide it the key, right? So I'll say if this dot cache has this key, then first of all, I will move it to the very front of our LRU cache. So I'll say this dot DLL dot move to front and just provide it with the current node. So to fetch the current node, I'll say this dot cache and this dot cache dot node. Now obviously we haven't added this node inside of our cache yet, but I will do that in this put function over here. So I'll just say this dot cache dot node and it will do its thing that it was doing over here. And then we're going to simply return it from this get function. Now for the put function, we're going to give it two things. First, the key and the value obviously that we're supposed to insert inside of our LRU cache. So first of all, I'm going to check, does this key already exist inside of our LRU cache? If it already does, then we're going to simply update the value for that key. So this dot cache of key dot value will be updated to this value, and let's move it to the very front of our LRU cache. So simply I'm going to do this again, and yep, it was moved to the very front. Else, I'm going to check if the size of this linked list is equal to the capacity, that if it's full, that if we are trying to insert something inside of our LRU cache and it's full, so instead of doing this, now we have access to the size, right? So this dot DLL dot size. So if the size is equal to the capacity of our LRU cache, then simply instead of remove last, we've called it this dot DLL dot remove from end, and this will remove it from the very end of our LRU cache. And after all of this has been done, we can simply add it to the front of our LRU cache. So I'll create a new node over here, const new node equals this dot DLL dot add to front. I'll just give this the key, and we're gonna also store it inside of our cache, this cache over here. So I'll say this dot cache of key. So with respect to that key, I'm going to store it, the value and the node, that is new node, which as you might know now, this node will be used over here in move to front. So yeah, that's pretty much it, and we can remove these old functions, we don't need them anymore. Alright, I think this should work. Let's test it out. I'm going to refresh our app. If we click on tab 2, it's loading. Okay, tab 1 data was loading, tab 3 data was loading. Okay, now if we click on any of these three are inside of our cache, right? So if we click on tab 2, you're going to see it has instantly loaded the data. And I'm assuming tab 1 is now the least recently used one. So if we go on to our doubly linked list, so 2, 3 and 1. Okay, now if we click on tab 4, you're going to see 1 will be removed from our doubly linked list. So inside of our doubly linked list, 4, 2 and 3. Yep, 1 was removed from our doubly linked list. So yeah, this is how you implement LRU cache by using doubly linked list, and this is the much more efficient way of implementing an LRU cache instead of using a singly linked list. So yep, that is it for this video. If you like this video, give this video a huge fat thumbs up, and don't forget to download my DSA with JavaScript ebook from the link in the description down below.